Good afternoon, everyone. Hope all is well and everything's going all right. Still see like one or two connecting, so I'll try to filibuster a little bit till they get in there. So hope everybody had a great weekend. Hope everybody's doing okay. We only did what 3132 last class, I believe. Of course, feel free to correct me or I see a head nodding, so thank you for that. So today we'll look at 3435. You guys are not held responsible for 33. Let me check to make
I have a
sure.
question on the homework.
Mm-hmm.
For 3.1, there's one of the questions, it gives you the numbers and it gives you the mean, and you need to find the missing number.
Mm-hmm.
How do I work that out? Do I just add the top and then what do I do?
Hold on, let me share my screen. That's the wrong button. Okay, so let's see. Let's go ahead. Oh, hold it. Let me get my pen up. All right. So let's say if I had I know my average, I know my mean is, let me put my screen there a little closer. Okay, let's say I know the mean is 700. And do they give you data values? Okay. So let's say
There was only like 6 and then the 7th was missing.
mm-hmm. So, and I'm just throwing in, just making some random numbers. And so let's say they give me three numbers, and I won't go so high, 700. Let's say it's 70. Give me three numbers, and the fourth number is missing. So that'll be my x. So what I would do is set it up as 70 is equal to 89 plus 90 plus 35 plus x, and then it would be divided by 4 because I have four numbers altogether. And then from there, I would solve. Of course, I go ahead and add these together to make one solid number. But then to solve for x, I would multiply both sides by 4 to cancel out this 4. And what would it be? 280 equal to x plus whatever that number is. And then subtract that number from this number. And then that'll be your answer. Yep,
Thank you.
yep, not a problem. All right. So since we are here, let's see. That's 3, 4. That's 3, 2. Right, 3, 3. Okay, so we're starting right here. All right. And we are recording. Okay, so let's look at 3.4. Like I said, last class we did 3132. Today we'll do 3435. And then after that, we'll be done with chapter 3. And that's it for chapter 3. And so your next test is going to be on 3 and 4. So you don't have to worry about jumping into another test right yet. But just know that that means we'll be done with 3 chapters, chapter 1, chapter 2. And that test is out there. And then this will be chapter 3. And like I said, we wouldn't be looking to get into another test until we have done chapter 4. But the thing about chapter 4 is only 3 sections. So that's why I say you got to get, make sure you stay on top of this stuff because it'll come quick if you're not careful. All right, so 3.4 measures of position and outliers. All right, so the first thing we'll look at is z-scores. That's going to be the distance a data value is from the mean in terms of standard deviations. I don't know if you remember last class, we talked about your empirical rule going out 1 standard deviation, 2 standard deviations, or 3 standard deviations. Well, z-scores allows you to be more precise. You can be 1.17, 2.34 standard deviations out. So you can get more precise on how far a data value is from the mean. So the general way of calculating your z-score will be your data value that you're trying to convert minus the mean divided by your standard deviation. Now, if you want to convert it to your symbolism. Your population has different symbols than your sample. So those are your symbols right there. But if you just remember your data value minus the mean divided by the standard deviation, whether you did it with the population or the sample, is still the same. Still the same process. All right. Are we okay? Of course, if I scroll up too far, let me know. So those two statements right there, your z-score is unitless. And this is just in case, I forgot if I chose any descriptive problems in my math lab, but concept, if they ask you about a z-score, your z-score is unitless. And it has a mean of 0, standard deviation of 1. So once you convert your data values to z-scores, and you will see this when we get into using the z-score chart and the applications, that's not till chapter 7, I believe. See chapter 6 or 7. Anyway, but right now they're just introducing the calculation of z-scores. But your mean will be in the middle, which will be 0. And then from there you will go out. So that's what they were giving reference to right there. But like I said, you'll see that as we go further. Is everybody good before I scroll up to the problem? Everybody's good. Okay. So
I'm sorry, could you scroll? I'll take a picture of it, but could you scroll up a little more?
how far?
To right here.
Okay.
Thank you. Got it.
Not a problem. So this problem right here, I don't know if I was a little sleepy when I wrote this out, but it's a few of my words a little ran together. So but yeah, it's still readable though, I believe. If not, just let me know if you have any questions on anything I've written. So it's to determine whether the Angels or Rockies had a relatively better run producing season. The Angels scored 773 runs and play in the American League, where the mean was 677.4 and standard deviation, I just used SD for standard deviation, was 51.7. The Rockies scored 755 runs and play in the National League, where the mean was 640 and standard deviation was 55.9. So if you know a little bit about baseball, American League, National League, they do things a little differently when it comes to I think lineup or something like that. I forgot the exact details, but I believe the pitcher has to hit in one league when the pitcher doesn't hit in the other league and stuff like that. So that's why the mean could be different depending on what league you're playing in. And so what this z-score allows is for you to be able to compare a performance or an outcome based on the mean of a certain group in relative to someone else's outcome and based on the mean in another group. So in other words, let's say if we had, SOLs, standardized testing in Virginia versus California, where the school systems are different in Virginia versus California. School systems are different, when you just go to a different region, maybe even a different city. So how they're taught, how they're tested, the standard may be up or down depending on what state you're in. So it would be better that you compare someone's test scores to those that are in Virginia and say how much better did that person do above the average in Virginia. Then how much better did another person do who was in California? How much better did they do above the average in California? So that's what this is about, just converting your data value and compare it to the average of that group. All right, so hopefully I gave you guys enough time to write. So once again, I'll read it out and then we'll look at what we would do in order to be able to compare the two. So determine whether the Angels or Rockies had a relatively better run producing season. The Angels scored 773 runs and play in the American League, where the mean was 677.4 and standard deviation was 51.7. The Rockies scored 755 runs and play in the National League, where the mean was 640 and standard deviation was 55.9. So first of all, whenever I'm doing any word problem, I like to write down the givens. So here are our given pieces of information. Angels, run score, our data value, the data value in question, or in comparison, 773, mean 677.4, standard deviation 51.7. Then the Rockies, 755, 640, 55.9. All right. And I scroll up. All right. So to convert them to z-scores, you take your data value, which is x, minus the mean, divided by the standard deviation. So that's what I did in both cases. 773 minus 677.4 divided by the 51.7 gives us 1.85. Then 755 minus 640 divided by 55.9 gives you 2.06. And then also right there, that last sentence, or that bottom sentence, always round your z-score to 2 decimal places. That's going to matter later on. So we might as well get into practice right now. We round our z-scores to 2 decimal places. Any questions? All right, can we scroll up? Talk about what these means. Everybody good? All right, so looking at the 1.85 and the 2.06, the Angels scored 1.85 standard deviations above the mean. So I underlined above just to make sure we understand why we're saying above. It is possible for your z-score to be negative. If it was negative, then we would have said they scored 1.85 below the mean. But since both of them are positive, we will be looking at above the mean. So the Angels scored 1.85 standard deviations above the mean. The Rockies scored 2.06 standard deviations above the mean. And so the last statement, this means that the Rockies had a better run producing year than the Angels. All right, questions on that?
None.
All right, sounds good. Thank you. All right, so let's look at, oh, was everybody finished copying? Anybody still copying? Before I scroll all the way up. See it here, no, okay. Okay, let's look at percentiles. The kth percentile of a set of data is a value such that k% of the observations are less than or equal to the value. The kth percentile is denoted by P sub k. So it's not PK, but the K is a little smaller. You know, it's a subscript in reference to the P. We'll see what that means in a second. Give you guys a chance to write what's in black. All right, everybody good? All right, so let's look at an example that talks about what was said in the black. Jennifer just received the results of her SAT exam. Her SAT math score of 600 is in the 74th percentile. What does this mean? All right, so this means that 74% of the people who took the exam scored 600 or less. or less. Remember, like that's what the percentile mean. Represent those who scored less, that or less than the value. So 74% of the people who took the exam scored 600 or less, and then 26% scored better. So we get the 26 from 100 minus the 74. Any questions? All right, can we scroll up? Everybody, all right. Quartiles. I believe this is the last thing in this section. Quartiles, they divide the data set into fourths. So if you notice here, we have our minimum. I see it says something about me being unstable. Am I good to go? Everybody throw a thumbs up so I can see somebody. Am I okay? Okay, cool. Appreciate that. I got a message saying my internet was unstable, so I just want to make sure you guys can hear me. So your quartiles divide your data
Got a
set.
little choppy for a minute, but you came back.
Okay, cool. Thank you. So your quartiles divide the data set into fourths. So you have your minimum value, which is your smallest value, maximum value, which is your largest value, which are your bookends, and then your quartiles in the middle, Q1, Q2, and Q3. So those are your quartiles, and it splits your data into 20, 25, 25%. Remember, your median splits your data into half. Your quartile splits your data into fourths. All right, so the way we will find them, we're going to list our data values from least to greatest. A lot of times people forget that one. Please don't forget it, because if you don't do that, then all the answers will be wrong moving forward. So you want to list your data values from least to greatest. Notice we find Q2 first, quartile 2 first. That is the median of the whole data set. That's just the middle value of the whole data set. It splits your data set in half. Okay, then we find Q1. That's the median or middle value of the first half of data. Q3 is the median of the second half of data. So all three of them are medians. All three of them are middle values. Find Q2 first to split your data set into half. Then you find Q1 to split the first half of data into half. And then Q3 will split the second half of data into half. All right, scrolling up. Everybody okay? Next thing is your interquartile range, IQR. Just the range of the middle 50% of data. And you will find that by taking Q3 and subtracting Q1 from it. Then we will be able to check for outliers. Outliers, we talked about them before, are very extreme values in reference to your data set. So this is going to allow us to create a number that if it's larger than this number or smaller than this number, it is an outlier, versus trying to eyeball it and say, hey man, that number looks very large or very small. We have upper fences and lower fences. So you take Q3 plus 1.5 times IQR. 1.5 is just a part of the formula. So Q3 plus 1.5 times your IQR. That will be your upper fence. Q1 minus 1.5 times your IQR will be your lower fence. And then in green, if a data value is greater than the upper fence, then it is an outlier. If a data value is less than the lower fence, then it is also an outlier. You know, it's only going to be one or the other. It can't be both, of course. If it's greater than the upper fence, then it will be an outlier. Or if it's less than the lower fence, it will be an outlier. All right. Any questions so far? Everybody good? All right. Let's scroll up.
I have a question.
Yep.
Where does the 1.5 come from?
Part of the formula. Yep. Don't think too deep about it. It's part of the formula. Yeah. You don't even want to know for real. Like, it's just part of the formula, which is, so somebody did some work, some background work. You know what I mean? And so, yeah. So now I'm going to list my data values from least to greatest. Your data set does not always have to be given to you from least to greatest. So you always want to check that. I just went ahead and put it from least to greatest. Also, let me erase this stuff. So you just see. Also, I count my data. What I normally do when I list my data values from least to greatest, I count how many data values I have and then write it in halves. In other words, this is my first half of data, and then this is my second half of data. I just go ahead and break it up, and it will help me with categorizing or finding my middle values and all the good stuff like that. So if I have 18 data values, I already know I have 9 data values in my first half of data, 9 data values in my second half of data. Like, so it's just a way to organize your data set so that you'll be able to find your quartiles easily versus even though you're writing them from least to greatest, just writing them all out in one straight line or just writing them all with no type of rhyme or reason. So I wrote 9 data values up top, then came down, wrote 9 data values under that. So I already split my data set into half. All right. So you don't have to do that, but you do have to write it from least to greatest. So it's up to you how you want to attack the problem. All right, and while you're writing, I guess I'll just read them. 180, 189, 370, 618, 735, 802, 1185, 1414, 1657, 1953, 2332, 2336, 3461, 4668, 6751, 9908, 10,034, 21,147. Those are all of our data values. All right, so since we have 18 data values, when it comes to finding your median, remember your first quartile that you will find will be quartile 2, Q2. That's the median of the whole data set. Now, if you have an even number of data values, remember you take the 2 middle values, add them together, and divide by 2. So that's going to be 1953 and 1657. And that's what I did right here. Now, remember, if it was an odd number, then I would have a legit middle value, and then that would need a calculation. I'll just take my middle value, and that's Q2. But once again, because I have an even number of data values, take the 2 middle values, add them together, divide by 2. So that's how I got 1805. All right.
I'm sorry. You had said you had to find the odd numbers.
No, we have an even number of data values. We have 18 data values. Because
Okay.
even, then you take the 2 middle values, add them together, and divide by 2. I say if you had an odd number of data values, that's if all you would do, you would have a middle value. Because you have an even number of data values, you don't have a middle value or true middle value. So that's why you have to do this. But if it was 19 data values instead of 18, then there would be a middle number. And so all you would do is pick out what that middle number is.
Okay.
So it's the same thing that we did back in, I think it was 3.1. When you talk about your medians, it's the same process. Yep. All right. So finding Q1 is going to be easy for us because there are 9 data values. So once again, going back to the fact that I have an odd number. So that means I do have a legit middle value, which would be 735. That's the number that's in the middle of my first half of data. For the second half of data, once again, I have 9 data values. So the number that's in the middle of that will be 4668. So before we go to another step, are we cool with how we found Q1, Q2, and Q3? All right, and then the last, we got to do our outliers. Next step is find IQR. So that's Q3 minus Q1. That's just 4668 minus 735, which would be 3933. All right, step 6. We want to determine our fences. So our upper fence, Q3 plus 1.5 times IQR. So 4668 plus 1.5 times 3933. 10,567.5 will be our upper fence. Everybody holding on to number 5, step 5. And then our lower fence, Q1 minus 1.5 times the RQR will give you negative 5,164.5. Any questions on the upper fence, lower fence? All right, so from there, are there any outliers? The answer is yes, because 21,147 is greater than that 10,567.5. So if we had something that was less than negative 5,164.5, then that would have been an outlier as well. But it's all about is something greater than this number or less than this number, that would be an outlier. All right, questions?
To find the fences, what do you multiply the 1.5 by? You multiply it by.
You said, well, our IQR, which is 3933, is that what you're asking about?
Oh, yes.
Yeah, so that came from right here.
Oh, okay, that's what it is.
All right, anything else before we go to the next thing? Make sure.
Just a quick question.
Mhm.
Can we have more than one outlier? Like, let's say the upper fence was just 10,000. So would our outliers be 10,034 and 21,147.
Absolutely. Yes, sir. Mm-hmm. Good
Thank
question. Good question. Yep. Yep. Nothing stops you from having multiple outliers. It's just the establishment of those fences. And the rule is if something is greater than the upper fence, if anything's less than the lower fence, it's an outlier. So, yep. And as a matter of fact, if you increase your data set, then more than likely you're going to have multiple outliers. Once you start getting, say you got 100 data values, it's possible to have multiple outliers. Yep. All right. Anything else from this section? That's it for 3.4. Any other things from this process? We're going to do this process again because 3.5 piggybacks on this, your outliers and everything like that. So we'll do it again. But any questions on what we've done up to this point? All right. So let's look at 3.5. 3.5 is pretty much doing the same thing that 3.4 ended with, just that they add the 5-number summary and box plots. Oh, we'll go my pen. So your 5-number summary is your minimum value, Q1, Q2, Q3, and your maximum value. All right. Now the box plots, graphical tools to use to compare groups of data. It consists of a box with lines that extend to the minimum and maximum values that are not outliers. Now going back to your 5-number summary, your minimum and maximum are what they are. It has nothing to do with outliers. So that's different. Now your box plot will only extend to the min and maximum values that are not outliers. So once you establish something as an outlier, then we're going to treat it a little different. And you'll see what I mean in a second. Is everybody done with the top? Okay, good. So these lines are called whiskers, and outliers are going to be replaced or represented by an asterisk. And so, minimize this a little bit. So that's how we would do our box plot. Notice the minimum and maximum value would be where the whiskers extend to, as long as they're on outliers. Q1, Q2, and Q3 would be lines of our box. And then any outliers, whether it's on the right side of the max or left side of the min, will be represented by asterisks. All right, any questions so far? And notice once again, this diagram is centered around your minimum, maximum, and Q1, Q2, Q3. So that's what I meant by this section depends on or leans on or piggybacks off of what we did in 3.4. So we're still dealing with our quartiles, and we're gonna have to find those. All right, let's scroll up. All right, so give the 5-number summary and sketch the box plot. So if they ask for those 3 things, they're not going to tell you find the quartiles, because it's understood that you have to find the quartiles in order to give the 5-number summary or sketch a box plot. So they don't have to tell you that. It's already understood that, excuse me, it's already understood that you have to do that in order to get those 2 things. So in the red, I was just stating the fact, I think I mentioned to you already, data set is not always written from least to greatest. Make sure this is the case before you move forward. So you always want to make sure your data set is written from least to greatest. So we're going to run through the process that we just finished doing last section once again. All right, anybody can I scroll up a little bit? It's right good right there. Anybody? Okay, good. So once again, your first step is to write data values from least to greatest. This time we have 21 data values. And so once again, I set up my data set, wrote it in halves. And let me erase this stuff. I'll put it back when we get there. So first half of data, second half of data, but since I have 21 values, I have a legit middle value right here. And that's why I wrote it right there in the middle. So once again, you don't have to organize your data this way. I always feel like it's easiest to do it this way to help me to be able to pick out what numbers are in the middle, what's my quartiles and so on. So erase that. Once again, we have 21 data values. Our legit middle value is 30.95. And we have 10 10 values in the first half of data, 10 values in the second half of data. All right. All right, so let's look at finding Q2. So I already mentioned that Q2 is our middle value, 30.95. So it's nothing for me to have to do. Our middle value is right there at 30.95. Now, there are 10 data values in our first half of data, so that's an even number. So that means there is no middle value. Since there's an even number, I need to take the two middle values, add them together and divide by 2. And that's what I did here. That's how I got Q1. Same thing with Q3. 10 data values in that second half of data. Take our two middle values, 37.05 plus 37.43. Add them together, divide by 2, 37.24. All right, questions? Any questions? So we now have Q1, Q2, and Q3. We can now find the IQR, Q3 minus Q1. Scroll all the way up. That's 11.18. All right, can we scroll? Now we can establish our fences. I had another class that called them limits instead of fences. So left limit, right limit, lower lift, lower. Your book called it lower fence, upper fence. So doesn't matter what terminology you use, but it's the same process. So Q1 minus 1.5 times your IQR is your left fence or lower fence. You guys doing lower. Gives us 9.29. Then our upper fence ends up being 54.01. Statement in red, just a reminder as to what our fences are for. If a value is less than the lower fence or greater than the upper fence, it is an outlier. All right, everybody good? All right, and then last step before we go to the 5-number summary, you want to determine if you have any outliers. And 54.63 barely made the cut. That is an outlier because it is greater than our upper fence. Any problems? Everybody good? All right, so there goes your 5-number summary. Smallest value and largest value will be number 1 and number 5. Minimum and maximum. Q1, 26.06. Q2, 30.95. Q3, 37.24. All right, everybody all right? So then the last thing, our box plot. So we have 19.95. Our whisker, don't forget our whiskers will extend out to the smallest and largest values that are not outliers. So don't forget our max here is 54.63, but we ended up finding out that was an outlier. So here our whisker extends to the largest value that was not an outlier, which is 49.17. But then we have this outlier asterisk for 54.63. And there you go. All right. Any questions? Any questions? All right. That's it. Yep. So that's it for chapter 3. Chapter 3, not too heavy. Say max is an outlier, but for 5, no, it is your maximum value, and that's what the 5-number summary is. That's your maximum value. But your whisker, your box plot only extends to the maximum value that is not an outlier. So we ended up finding out that 54.63 was an outlier. So when it comes to your box plot, it won't extend out to the 54.63, but you still use it, in your 5-number summary. Yeah. Mm-hmm. Yeah. And I think your book mentions it, but that's why they call this one a modified box plot, because it doesn't extend all the way to, if it's an outlier, it doesn't extend that way. But this is what your book wants you to do. So, yeah. All right. Questions. We good? Straight. Anybody else? So, like I mentioned, this is it for chapter 3. You may not have any questions now, but some questions may pop up once you actually get into your homeworks. If you haven't gotten to this section or whatever, or you might just be good. It's not really about the calculation, but the application and or the process when it comes to these. So you may be okay with it. Make sure you try the stuff out. See if you get stuck on anything. I'll open up the floor for questions first. Whether it be on chapter 1, chapter 2, or chapter 3. If you try anything, got stuck on it, next class, most definitely bring it to class so we can talk it out. If not, then we'll just go ahead and flow with chapter 4 stuff. Anything before we close out today? Anything. So always, like I say, always take advantage of the fact that I'm not hitting you with a bunch of material from start to finish. Remember, this class is 1 to 3 o'clock. So really, I'm supposed to hold you for a whole 2 hours. I just really believe in making better use of your time versus me lecturing you for 2 hours. Give you the opportunity to get into my math lab and get to your assignments. And then of course I don't want to say a whole bunch of stuff and you don't get a chance to process everything. You know what I mean? So I just want to hit you with enough that give you something to chew on until the next time. So any questions before we close?
What was that math website that you used for the standard deviation?
Easycalculation.com. Yep, right there. I kind of scribbled it though. Easycalculation.com. So when I Google it though, because sometimes their website can be a little funky, I would Google standard deviation easycalculation.com. So if you put standard deviation in front of it, or just standard deviation easy calculation, then it'll pop. That'll be the first thing to pop up. Standard deviation easy calculation. All right. Anybody else? Everybody good? All right. So that's it for today. You guys have a good one. Be safe. I will see you on next class.
Professor, I needed to ask you something.
Yep, sure.
Private.
Now, you want me to cut off the recording? I don't know what you.
Yeah. Could you?
Okay. All right, give me a second. All right. So if y'all don't have anything else, then you guys are free to go. I'm going to stop recording and see what Mr. Gurley has to say.
Thank you.
All right. Thank you. You have a good one.
Thank you. Have a good day.
Take care.